Section 2.8, we're going to be solving linear inequalities. All right, as a reminder, if you have an inequality symbol, this is an example, we would read that is less than or equal to, is greater than or equal to. So when we have a linear inequality in one variable, that would be something like this: x plus 5 is less than 2, or z minus 3/4 is greater than or equal to 5. Let's see. All right. Okay. There are different ways to indicate an inequality. We can write it as what's called a solution set. We can write it on a number line. We can use interval notation. So we are going to need to know this. You're going to need to know this all different ways. I'm going to require that you be able to give me any of the different ways to indicate an inequality. So if I have this, for example, x, okay, we would read that as, so we've got braces here. That means we have a set. Braces indicate that we have a set. So we would say the set of all x's. So this tells me what type of variable. So if I had a y over here, I would put a y here. If I had I could put an ordered pair here, in which case I would have to have an equation with two variables, or inequality with two variables. So this just says, okay, what we have in the set, we have variables, and we're going to call them x. Then this line straight up and down kind of looks like half of an absolute value. It's not an absolute value. We read that as such that x is less than or equal to 2. So one more time. The set of all x such that x is less than or equal to 2. So what does that mean? Well, if I were to draw a number line, and here is my 2, I want numbers less than or equal to 2, which indicates these numbers right here. And because it's equal to, I am going to use a bracket rather than parentheses. Now, you may be used to open and close circles. That's typically the notation that they use for K through 12. So if you had a class, an algebra class, they probably used an open or a closed circle. In this case, they would use a closed circle. But once you go to college, and this class is called college prep, so the goal is to prepare you for a college class. In college, they use this notation where they use a bracket to indicate the equal to, or they would use parentheses to indicate without the equal to. So in this class, we're going to use brackets and parentheses. Brackets, in this case, a bracket. All right. The other thing you're going to need to know is what's called interval notation. This is probably new for you. I'm not sure if you've had a class before that talked about interval notation, but it is something that you need to know. When you do interval notation, you are going to have a number on the left and you're going to have a number on the right. The number on the left is always the furthest to the left that the interval goes, and the number on the right is the furthest to the right that the interval goes. Meaning, if we look at this shading right here, my shading keeps on going and it doesn't actually stop until we get to negative infinity. So my shading goes all the way to the left to negative infinity, and my shading goes all the way to the right to a positive 2. So my negative infinity has to be on the left and my 2 has to be on the right. Just like you would shade it. For example, if I wanted to go less than or equal to 2, I would not shade in this direction. Same reason, you have to have your negative infinity on the left and your positive 2 on the right. Now with infinity, infinity always gets parentheses. However, the 2 is included. There is an equal sign here. We used a bracket on the number line, so we're going to put a bracket around the 2. The biggest reason why colleges use bracket and parentheses on the number line is because we use bracket and parentheses with our interval notation. It's called interval notation. Okay, so whatever we used on the number line, that's the notation we're going to use for our interval notation. And infinity always gets parentheses. Okay, so you will need to know this, you will need to know this, and you'll need to know this. Be especially careful to put farthest to the left on the left side of the interval and farthest to the right on the right side of the interval. I cannot tell you how many students will try and tell me this, and they will do this. And this right here, there's nothing mathematically that makes sense about that. It is completely nonsensical. It doesn't make sense mathematically because negative infinity is smaller than the 2, so it's backwards. It just doesn't make any sense. Okay, so I already talked about this. X is less than or equal to 2. Notice my bracket, and here's I'm going to give you a big, huge hint, guys. When you are trying to graph, if you put the variable on the left, do you see this arrow? This arrow right here is pointing to the left. That's the direction you're going to shade. As long as your variable is on the left side, the arrow will point in the direction that you're going to shade. All right, we already talked about this interval notation. And the negative infinity symbol, it's not an actual number, and that's why we always have to use parentheses. And what else? Positive infinity also will get parentheses. All right, so my computer froze up for just a second. So my variable's on the left is greater than or equal to 3. So at the 3, okay, it's pointing towards the right, so I am going to shade towards the right. And because it's equal to, I am going to put a bracket. Now notice the bracket is pointing in a different direction than the last example we did. Well, the bracket has to actually surround the shading. Bracket has to surround the shading. So I would not put a bracket going this way and then shade to the right. That, again, doesn't make sense mathematically. We also want it in interval notation. So since my 3 is the end point for my shading on the left side, I'm going to put my 3 first. And it keeps on going to positive infinity on the right side. I'm going to put my positive infinity on the right side of my interval. My 3 had a bracket on it, so I'm going to put a bracket here. And infinity always gets parentheses. So now this one, notice my variable is on the right side. It's so much easier to graph if the variable's on the left. I don't know if you guys remember how to reverse this, but you reverse it. So notice it's pointing little point towards the X, so my little point has to go towards the X when I reverse sides. In other words, if I flipped sides, I also have to flip the symbol. All right, so I'm going to go to -4. It's pointing to the left. My variable's on the left, so I'm going to shade to the left. This does not include an equal to line underneath that inequality, so I'm going to use parentheses on the -4. And we want interval notation, so it keeps on going. So my negative infinity out here. Remember, the negative infinity always has to go on the left side of my interval. And my shading stops here on -4. And I use parentheses on the -4. And my infinity always gets parentheses. All right, let me get this out of the way briefly. So a parenthesis indicates that an endpoint is not included. And bracket indicates that an endpoint is included. We always use parentheses for negative infinity or positive infinity. And if I say something like the set of all real numbers, that would be negative infinity to positive infinity, and interval notation would look like this. All right, so let's suppose I want to solve an inequality, a linear inequality. And we solve an inequality exactly the same way we would solve an equation, with one exception, and the one exception isn't yet. I will let you know when we get to that exception. So more than ever, we really, really, really want our variable to be positive. So I'm going to subtract my 7x, and I'm going to add 1, and I have x is less than 3. So it says graph the solution set, and when you do your homework, all you have to do is do whatever the directions say. It's either going to ask for interval or a graph, usually not both, sometimes both, but usually not. But for our purposes, for practice, we're going to give both the graph and the interval notation. So notice it does not have the equal to symbol underneath, so I'm going to use parentheses. And since my shading on the left side goes out here to negative infinity, so that's going to be on the left, and negative infinity always goes on the left, always, always, always. 3, the shading stops here at 3, so I'm going to put my 3 on the right, parentheses, and infinity always gets parentheses. So there is my interval notation. Okay, multiplication property. So I said solving an inequality is exactly the same with one exception. Here we're going to get our one exception. Let's take a look at this. Suppose I know that 3 is less than 7. We know that's to be true. 3 is smaller than 7. And if I multiply both sides of this inequality, I get 6 is less than 14, and that is still true. So I could multiply both sides by a +2, and I get a true statement. Not a problem. The problem comes in when I want to multiply both sides of an inequality by a negative number. So if I multiply a 3 by -5 and the 7 by -5, I get -15 is smaller than -35, which is false. So whenever you're multiplying or dividing, multiply or divide, an inequality by a negative number, we do have to remember to reverse the symbol to get a true statement. Multiply by a positive number, that's fine. We don't have to switch the symbol. But if we multiply or divide by a negative number, that's when we have to reverse the symbol. Reverse the direction of the inequality when we multiply or divide by a negative number. That's important. Students forget it all the time. So please, please, please remind yourself, if you multiply or divide by a negative number, you have to reverse the symbol. All right. So this is just kind of a summary of what we were just talking about. Okay. All right, so let's do this example. We have -2 times r is greater than -12. Because we're dividing by a -2, we do have to remember to reverse that symbol. So we're going to have r is less than, don't forget to reverse the symbol, 6. And the r is on the left and it's pointing to the left, so we're going to shade to the left. We do not have the equal symbol underneath, so we're going to use parentheses. And again, it goes out to negative infinity on the left, and the shading stops at 6 on the right, parentheses on the 6, and infinity always gets parentheses. All right, to avoid making this video extra long, I am going to stop here, and then I will finish the material in another video.